Two more problems from the homework. Multi-step equations again. And this time we're talking about this consecutive integers type of problem. The first question says find three consecutive integers whose sum is 96. Now, a lot of times when I see students approach this problem, they'll do something like this. X plus y plus z equals 96. Because they know the three numbers are different from each other. An example of consecutive integers would be like 5, 6, 7. Three different numbers that are in a row. They're consecutive and they're integers, positive or negative whole numbers. However, if you have more than one variable type within an equation, it makes it way harder to solve and way too advanced. So instead of that, what we're going to do is be a little bit more intelligent with our labeling of variables. I'll call the first one, and I know it's not 5, because 5 plus 6 plus 7 is not 96. But I'll call the first one x, because I'm not sure what it is. But if I call this x, I could call this one something in terms of x, because it's the one after x. So what am I going to call that? Well, here's where I get creative. I'm going to call it the one after x, x plus 1. And then I'm going to add that, the one that's 2 after x. So what should I call that? You guessed it, x plus 2. So if this was 5, this would be 5 plus 1 is 6. 5 plus 2 is 7. Although that's not really the answer. Equals 96. Well, why be so fancy? What's the point of doing that instead of writing x, y, and z, like terms? I can go ahead and now combine like terms here and simplify that equation. X plus the commutative property, x, is 3x plus 3 equals 96. Now, that doesn't finish the problem. But if I subtract 3 from both sides and then divide by 3 from both sides, I'll figure out what x is. I can add 1 to that number to figure out what the second term is, and add 2 to that number to figure out what the third term is. And then I would have found my 3 consecutive integers. What if it says find 3 consecutive odd integers? Well, now it would be, suppose it was 5, and then 7, and then 9. 5, 7, and 9 are 3 consecutive odd integers, but their sum isn't 176. However, I'm going to use the same strategy with a little twist in order to solve the problem. So I'll begin by calling my first odd integer x, plus, now I have to think about how do I get here? How do I get to my next odd integer? Well, I'm going to have to add 2 to it. I'm going to have to call that x plus 2. This is my first odd integer. That's my second odd integer. And then for my third odd integer, I start at x, 1, 2, 3, 4. I'm going to have to call that x plus 4. 5 plus 4 would give me another odd integer. And that will equal 176. Again, I'm going to combine like terms, x plus commutative property, x, 3x plus 6 equals 176. Subtract 6 on both sides, divided by 3. I get my first number. I add 2 to that, I get my second number. I add 4 to that, I get my third number. Last thing, what if it said find 3 consecutive even integers? What if it said even instead of odd? So I'm looking to go from here to here to here. Well, there is no problem on the board that says that, but if I'm looking to go from consecutive even integers, I could call this x. I could still call this x plus 2, and I could still call, from here, 1, 2, 3, 4. I could still call that x plus 4. It's kind of interesting that whether you want consecutive odd integers or consecutive even integers, you're going to use the same x, x plus 2, x plus 4. Because the adding 2 is just allowing you to hop over the in-between numbers, whether they're even or odd.